Okay, so here we go. We're going to start with weather. This is for our first section in Chapter 1. Now, what is weather? Well, weather is the state of the atmosphere. And if you remember from your earlier Earth science, what is the atmosphere? The atmosphere is that envelope of gases all the way around the Earth. So here's the Earth and the envelope of gases. And there's lots of layers to the atmosphere, but this whole thing is our atmosphere. Okay, so the weather is going to be the state of our atmosphere. Well, what's going to affect the weather? Well, there are some main points that we're going to be looking at. First of all, what we're going to look at, and that's what's going to be the focus of this section, is heat energy. And where do we get our heat energy? Well, of course, it's from the sun. Also, air pressure is going to affect the state of the atmosphere, as are the winds and the amount of moisture. So, heat energy. Woo, we got a lot of stuff going on here, but let's take a look at it. So we have heat energy. It's coming from the sun. There's our little happy sun. And what's coming out of it there? That's the radiant energy. The radiant energy that's coming out. This is UV rays and IR radiation, as well as other things. But this is all a part of the electromagnetic spectrum. So write that down. That's not in your book. Electromagnetic spectrum. Now, this radiant energy comes from the sun, hits our atmosphere. Okay, and there's a couple of different layers of atmosphere I have here. Hits the atmosphere, and what can happen to it? Well, it can be bounced off. It can be reflected by water and dust particles that are in the atmosphere. It can also be absorbed by ozone. That's O3. And we've all heard about the ozone and the ozone layer and the ozone hole. But part of it gets absorbed by the ozone way up high in the atmosphere. Some of it gets through that ozone layer, and it can be bounced off again by water and dust particles. Some of it can be absorbed by the clouds, and some of it actually gets through. And the stuff that actually gets down to the earth either is reflected by the earth or it's absorbed. And that absorbed is very important to us because that's what heats our earth up. So, summarizing what I just set up here in this big jumbled picture. Radiant energy from the sun. It can be reflected by dust or water droplets. It can be absorbed by ozone, which is O3. It can be reflected by particles lower in the atmosphere. That's down here. Right? Again, that's dust and water. It can be absorbed by the clouds, or it can be absorbed or reflected by the earth. When it's absorbed by the earth, that's what heats our earth up. So what then? Well, what happens once something gets heated up? Well, we're going to spread it through the earth. One way we spread it through is through conduction. Conduction is through touching, things that touch. Convection, which is through movement and flowing of fluids. And through radiation, which is when something's warm and it radiates the heat. Conduction, we're talking about transferring heat directly. We have to be touching. Things have to be touching. This is very minor for Earth. Earth itself is a pretty poor conductor, and if you remember from your other science classes, conductors of heat are the ones that conduct heat, that transfer heat from one spot to another. And the Earth isn't so good at that. So it can do it, but it's pretty minor. The big thing for us is going to be convection. Convection is how energy is going to flow. And if you remember, warm air, a couple things about it, it's less dense, and sometimes we call it lighter. Right? So if it's less dense, what happens to it? Well, if it's down here and it gets warm, it floats up. Now, cool air, which becomes more dense or heavier, if we have air that's up on top and it starts to cool, it's going to fall down. So what happens? Warm air goes up, cools, falls down. Warms up, comes up, cools, falls down. And this cycle right here, this is called a convection current. This is very important for our atmosphere because the Earth absorbs the heat down here, warms up that air. That air, when it gets warm, rises up into the upper atmosphere where it cools down. When it cools down, it falls down to Earth, and when it gets warmed up again by that heat that's being added. And this cycle spreads that heat around the Earth. Radiation also happens with the Earth. And that's when energy goes through empty space. That's our electromagnetic energy that I already talked about coming from the sun, the UV radiation. You know, the sun, when it lets go of energy, there's nothing, well, there's very little in Earth in between the sun and the Earth. And so it's transferring without any matter at all. Now, if you look in your book on page 14, there's a very nice picture of this. Now, these processes, this sun radiates the energy, goes through empty space, hits the Earth. All right, so either we are absorbing it or reflecting it. Now, the stuff that gets through and gets absorbed, our UV and our IR radiation that gets through the atmosphere and actually comes down to the Earth and gets absorbed. Some of it is radiated off by conduction, right? Some of it is transferred around by convection. Now, what keeps this heat here? Well, what keeps this heat here are our greenhouse gases. Greenhouse gases include things like carbon dioxide, water vapor is actually a greenhouse gas, methane, also known as cow or pig farts, nitrous oxide, N2O, ozone, which we have to have in the atmosphere to filter out some of that UV radiation, and then also CFCs. This is our chlorofluorocarbonated hydrocarbons. This is what we have in our spray cans, or, well, not anymore, what we used to have in our spray cans. Now, the greenhouse gases, what do? They trap the heat, kind of like your car window. So if you can imagine, this would be like your car window. The sun shines in, it warms everything up in here. Heat can't get back out because those greenhouse gases up here, the greenhouse gases, which are up here, when the heat tries to come out, it says nope, and it pumps it right back into the Earth. Now, much like our car window. Now, it's very important right here. Life on Earth depends on the greenhouse effect. If we did not have greenhouse gases, the temperature on Earth would be much too cold for us to live in. So while we do have to be careful about putting man-made components into the atmosphere, remember the only reason we live on Earth is because of this greenhouse effect. Okay, so on Earth, we also have temperature variations, and we all know that, right? I mean, there's a very different temperature that you can expect in Michigan than in Florida or in Ecuador or in the Sahara Desert. And what are the factors that affect this temperature variation? Well, let's remember, what is the equator? Remember that line in the middle of the Earth? Well, along the equator, which is this line right here in the middle of the Earth, that gets the most direct sunlight, right? So if I have a beam of sunlight coming from the sun to the Earth and it hits in a pretty small spot. So all of this energy that is direct goes right in here and gets very, very concentrated, very small area. So it gets absorbed, heats up the best. Now the poles, both the North and the South Pole, if you imagine I have another energy ray of energy coming from the sun. When it hits the Earth, it's glancing off. So this energy gets spread over this whole area right here, right? So instead of being in this small area where it all gets absorbed, it's spread out over a big, long area. So it heats up the least. So even though both the equator and the poles get the same amount of energy from the sun, the equator is much more concentrated, so it heats up. Whereas the poles, it's much more spread out. So how do we measure the temperature? Well, we know how we measure it. We measure it with a thermometer. Many of us have these outside our back door so we can see what temperature it is. And our thermometers are in two different degrees. Celsius, which is degrees Celsius. This is our SI unit, our SI unit. And the Celsius is based on water. It's the older of our scales. And water freezes at 0 degrees Celsius. And they define it as boiling at 100 degrees Celsius. So what they did is they measured, put a thermometer in, and when water froze, they marked it, said that's 0. And then they put it in when water boiled. They marked it, said that's 100, and then they just divided it all up into 100 spots in between. And that's how we get our degrees Celsius. Now, the one that we are most familiar with is our Fahrenheit scale, which is a different scale. And for us, 32 degrees Fahrenheit is when water freezes, and 212 degrees Fahrenheit is when water boils. So that means that 0 degrees Celsius is equal to 32 Fahrenheit, and 100 degrees Celsius is 212 degrees Fahrenheit. Now, unfortunately for us, the size of a degree Celsius is not the same as the size of a Fahrenheit. So here's an important equation. You might want to write this down, and you want to practice with it. This is just like in our math class. This would be a function. So we have our degrees Celsius is going to be equal to, and we have our parentheses. Don't forget your order of operations here. We have our parentheses. So we have our degrees Fahrenheit, whatever the temperature is in Fahrenheit, subtract from that 32. Then that whole thing we multiply by 5/9, and that will give us our degrees Celsius. So that's it for our first section of Earth Science, and see you back for the next one.